Okay, hi everyone. So for those who don't know me, I'm Alan, a software developer at Quantox, and I mostly work with JavaScript, React Native, and Node.js. And today we're going to talk about Bulletproof React. It is an architecture that it is a proposal for an architecture on how to build React applications. So it requires some prior React knowledge in order to pick up the concepts, but it's mostly presenting a way of creating a React applications using the best tools in the ecosystem with good project structure that would scale well for any size of project. And some of these things that we are going to mention will be transferable to other libraries and frameworks, but it is related to React. So, how many of you have used React and using React? Okay, so that's quite amount. So we all know that React is simple in the way that it is pretty easy to get started. It is a small declarative API where you declare, so you describe a UI and you get some markup via JSX, which gives additional improvements by abstracting React create element methods. And another good thing that I like about it in comparison to other frameworks is that it's just JavaScript and it doesn't have any magical things such as, basically you write just JavaScript. Okay, and it is simple until it isn't anymore. So the thing is that React is too flexible. There is no official architectural recommendations, so we are able to structure our application however we want. It has a huge community and a very diverse ecosystem, meaning that we have different solutions. So we have solutions for any problem we might have in an application. And by having so many choices, it might lead to analysis paralysis where we don't know how to decide for which solution we want to implement in our project. So when we start an average React application, some of the things that we need to consider is project configuration, project structure, having some style guide, how we deal with components and styling. We need to consider an API layer, state management, testing, error handling, security, performance, deployment, and maybe some other things that I didn't mention here. And yeah, so it's a lot to take for someone when it starts a new project. Okay, so let's get started with an application that we want to demonstrate and to see how some of these concepts would apply to another application. So we have users that during the registration create a team where other users can join and they can start discussions between each other. So here we have a demo app, but so this is the data model of the application. So we have user discussions, comments, and team, and we have two roles for the users in order to demonstrate authentication and authorization for whether something is allowed to be accessible or not. Okay, so here is a short video of the demo app. 1 moment. So here is the registration. Now we can see logging in. So here we are creating a discussion. Now when we have the discussion, we can update it. on a newly created discussion, we can add some comments. And then so based on whether we have the permissions, we can delete our comments, and we can delete discussions if we are the admin of the team. So that's the demo app. And let's start with the first thing here. So we have a project configuration where we need to consider several different things, such as setup, linting, formatting, type checking, Git hooks, and absolute imports. So when we say setup, I mean by what we use as a baseline for our project. So to bootstrap a project, so the most common ones are create React app, which gives you a great speed for starting a new project without having to deal with web configurations and other different configurations. But it is a client-side only application. Then we have Next.js, which supports multiple rendering strategies, and it can be, so it might be even a better option because it gives you a speed for setting it up, but then it gives you even more possibilities. Then we have Gatsby.js, which until recently, it was just considered a static site generator, but this week, I think, they released version 4, where they also support server-side rendering and some other things. And Vite.js is a new tool that is built on top of ESBuild, which is a bundler that was built with Golang, and its advantages over Webpack is its speed, so it's 50 or 100 times faster by their metrics on their website. And we always have the option to configure it ourselves, but that would take a lot of work. So we won't need to hire another person to just handle the configuration and all the dependencies for it. So when we talk about linting, we want to be consistent with our code base. And in order to do that, we can implement some linting rules where we want to enforce all the developers in the team to respect those rules. And that would keep the code base clean and consistent. Pretty much same with formatting, where the computer will format our code. So the most common formatting tool in JavaScript world is Prettier, and we can configure it to work together with ESLint, and it is also very well integrated with our IDEs such as VS Code. So in my example, when I try to save something and it doesn't format, that means that I have some compilation or syntactic error that I quickly can fix. Okay, so about type checking, it is a controversial topic whether we should do that or not, especially on smaller applications. But I think having TypeScript on any non-trivial application is important to have. So it is a static analysis tool for analyzing your code and check for typing errors you might have. So it will catch your errors during a build time, where if you have some errors, the compiler would fail. It is especially useful during large refactors where you want to be safe that you refactor everything properly. And so it can also serve as a good code-based documentation. Git Hooks is another nice tool to have. It gives you option to have, Husky is a nice tool to have, and it gives you the opportunity to integrate Git Hooks where you want to validate some piece of code before you push it to your repository. That way, keeping your repository clean all the time. So here we have a simple validation script that we run when we try to commit our code with Git pre-commit hook. Yeah. Then absolute imports, which should always be configured because it will allow us to move our code much better around than if we have relative imports where we have so many dots in the import statements. So here it would be a setup for configuring this in the ts config file, and I like to specify everything starting with @ and then / something that would redirect everything to source. That way, it is short enough to write import statements, but on the other hand, it will not conflict with other node modules, which would happen if you don't have this and you would consider the root directly. Okay, so project structure. That is also one thing that React is very flexible with, and there is no official guide on how to do it. So I found this nice tweet by Dan Abramov where he says that ideal project structure would be to just move the files around until it feels right. And yeah, so that's how many of us do in order to find the right project structure. Yeah, so here we can observe one project structure where we have, let's consider a source where we have different assets, components. So assets would be assets globally available to all the modules. Components also shareable, so you would include, for example, UI components, library, and stuff like that. Config, where I like to re-export all the variables that come from .env files. Then we have features that we'll talk about a bit later. Hooks, also all the reusable hooks that we can reuse throughout the entire application. Lib, where I want to, so we can have libs that are internal or external. Internal lib would be something that we built for just this application, but external lib would be some configurations for some external library, but we want to leave it in our code base. Routes, yeah, we can configure routes, global stores, global types, and global utils. But let's go to the features folder. So let's say we have this awesome feature. An ideal structure here would be that it would have its own API layer where we want to export all the API request declarations and all the API hooks that would use these request declarations. Also, as we could use it for, so we have assets that we could use for all the static assets that are related to just this awesome feature, because if it is not being used anywhere else, there is no need to pollute the global assets folder, where we would use just something that is required by multiple things. The same would apply for components, hooks, routes, stores, types, and utils. So we would basically have the similar structure as we have in the source folder, but narrowed down to just as a feature, a domain-specific feature, yeah. And one thing that this feature should have is the index file, which should behave as the entry point for this feature. So it should serve as a public API for this. So anything you want to from this feature to be used in other modules, you would have to re-export from this. Okay, so about components, there are a couple of tips that are nice to keep in mind, such as collocating everything as close as possible to where it's being used. So there is no reason to separate our code base by type of. So let's say we add everything. So how should I put it? Let's say we added all the components inside the components folder, and we have hundreds of components. There is no need to keep your components as close as possible to where they're being required. Avoid large components with nested rendering functions, and that means that if our component is large and have these kinds of rendering functions, that means that these rendering functions should be separated into its own components. And it is fine if you want to have these components in the same file, you just don't re-export them. They're just being used by this one component. And so limit the number of props your component is accepting as the input. So I would say maximum 4 or 5 props. If you have 10 or 15 props required, that means that you should either separate your components, or you should think about applying a composition where you would pass the piece of code that would require these additional props as children or as slots. And yeah, so any reuse of the components that could be shared, you could abstract into a components library which you could later separate into a different library that could be shared and reused through other projects as well. Okay, so when we talk about component libraries, we want to, our UI libraries, it is a good thing that we build them on top of some base. So we have some baseline for these components. They're well tested, and they're also accessible. So they have accessibility in mind. So they can be styled and headless component libraries. So for example, some style component libraries, and this is not style components, but style component libraries. So Chakra UI, which I think I would recommend to everyone to try. And Design and MUI, which was until recently Material UI. Yeah, Material UI, but they rebranded it, and it has some nice features in the version 5. And the headless component libraries are the ones that don't come pre-styled, but it is on us to implement the styles, and it is very useful if we have a design system to implement, so we don't have to rewrite and to modify the existing styles of the existing components, but we can reuse all the extra logic for the components. So the most common ones are React, Headless UI, if you are familiar with Tailwind, Radix, and React Area. And with these libraries, when implementing a component library, you would consider some styling solutions. So you could either go with vanilla CSS, Sass, SCSS, but I like CSS in JS solutions such as Emotion, Style Components, Tailwind, which is not a CSS in JS, but is also pretty nice, has pretty nice API to work with, CSS modules, stitches, and linearia. Now keep in mind that some of these, so for example, emotion and style components create the class names during the runtime, which might affect your performance in some cases. And these others build their class names during the build time. So all the class names come predefined. And this would be some good combinations. So if you need to prototyping something quickly, Chakra UI and Emotion is a good option. If you're into Tailwind, you can consider Headless UI and Tailwind, and Redux UI and Stitches is also a nice option. And yeah, so in order to document these components you created, it is a nice thing to create a storybook for those. So you can think of it as a catalog of your components that your application is using, and it is very useful for developers to develop these components and also for other members that are coming to the project so they can easily discover these components, because if they are hidden somewhere in the code they will never know they exist. And also what's good with it is that it comes with good documentation where you can see all the props that it should accept, and in combination with TypeScript you can change these props directly in the Storybook, so you can see the changes directly without defining them anywhere else. And it all comes free with TypeScript and Storybook. Okay, so now we are moving a bit from the UI and we are onto the API layer. So the most common things we use for the API layers are either GraphQL or RESTful APIs, and some things that we should keep in mind no matter which strategy we are using is to have a single instance of the API client, which means we should define that instance at once and then reuse it through the application instead of coding the baseline for it every time. So here would be an example code of the API client, and we have Axios here where we create an instance with the base URL and we define some interceptors here. And we define it only once, as we discussed in the lib folder, because it is our adjustment of the Axios library, and then we are good to go everywhere else. And we should also keep in mind that we should separate and define somewhere the request declarations. So what should be considered a request declaration? So if we are using, for example, Axios, it would be a function returning the call of Axios methods. So for example, here is an example of the API declaration. So let's say here we have get discussions. So we define the type, return type of it, and we return the calling to this discussion endpoint, and that's it. And if it was a GraphQL API, then we would just export of the GraphQL declarations wrapped inside the GQL tags. Okay, so state management. Yeah. So state management could be, so it's important that we think of our state in our application based on what it is being used for and how it's being set and changed. So we can split it into 5 categories here, but there might be even more. So we have a component state where we have, okay, so let me jump. So component state is just something that we use in one component and we never use it again, or we might even pass to as a prop to a child component, but that doesn't matter. It is not needed to be global. And let's say, for example, so here this would be, it's simple, so just I use state declaration for site where open. It is not being opened anywhere else, so there is no need to move it to a global state. Then we have the application state, which should be considered global, and it should be accessible anywhere from anywhere else in the code. So we use it for opening models, notifications, changing color mode, etc. In this application, we are using it for showing the notifications. So we have this store made in Zustand library, where we have this simple store that has the notification, and it has the methods to add and dismiss the notification. And it is a pretty small and simple library with similar API to Redux, but it is much simpler and with less boilerplate. So some of the good options for the application state are, so we all know that we can use context and hooks, and it is fine for smaller applications. But if you move to something larger where you have different pieces of state you want to structure in a better way, then you might consider Redux, especially with Redux Toolkit, which gives us nice defaults for defining reducers. So they support something called slices, where by creating a slice you would get in return all the action creators, the reducers, and types for that piece of state. Also, another good option is MobX, Zustand, as we mentioned, Jotai, and Recoil. These last two are atomically based state management tools, which are good if we want to track a large amount of objects in our application that are rendered at the same time. Yeah. So another type of state is server's cache state. So this is a piece of state that comes from the server, and it should be cached somewhere on the client for future usage. So basically this state should always be in sync with what is on the server. So good solutions for that are React Query, SWR, and they support, so they are agnostic of what type of API you're using it. You can use it with either GraphQL or RESTful APIs, as long as you pass a function returning a promise as a fetcher function. And then we have Apollo Client and Oracle for GraphQL APIs, and Redux Toolkit Query, which is something new that implements some of these nice things, but within the Redux store. And let's see an example how the definition of that would look like. Okay, so we already seen our get discussions of API call declaration, but let's see how we should use that piece of state. So we are re-exporting useDiscussions hook, which is actually a call result of the use query, which comes from React Query library, and we just pass inside it a query key, which tracks by which key that piece of state is being cached, and the query function that we already have. But it is also nice to export this function if you want to use it outside the hook itself. And one good thing here is that all the state that is in this cache could be considered as a global state, because you could access it anywhere else if you needed, and you could modify it easily. And also form state could be considered a different type of state, because it is only a state that should track the values in the form and nothing else. And yeah, so we have this this form component declared here. So we use a React hook form, and we create some nice abstraction here for the form to be used with any fields we want to. So let's say here, for example, here usage would look like something similar here. So we would define the schema for the validation. We would define the types for the registering values, and then we would call the form with these types, and then we could pass the onSubmit function schema and some other options, and then we would get these values from the React hook form to register it on our fields. And this is a nice thing to have, because we can affect how our form layout would look like without having some additional modifications. As we mentioned, so we can build our custom forms with just React state, or we could either use uncontrolled components where we would just pick everything from the event object. We can use Formic, Final Form, and Yup and Zod are good validation libraries to be used in combination with the form libraries. And one more piece of state that we sometimes overlook is the URL state. And yeah, so this is a state that comes from our address bar in the browser. So basically so we can consider this as a source of truth of any dynamic parameters that our address bar could have. So for example, in this slide, for example, slide index and step index could be considered a source of state, and there is no need to synchronize it with the internal state of the application. And these kind of things also allow the application to be deep linked, so you could, so let's say here we want to enter it again. If we kept these indexes in some internal state, then if we refresh the application here, it would return to the slide number 1, and now it's still in the same spot. And testing. So how many of you write tests in your JavaScript applications? Well, not many. Yeah, but yeah, that's not done as much as it should. But that's mostly because we are not really sure what to test on the front end in the first place. Is it the data or is it the UI? And it's really tricky to define. So yeah, so this is a nice tweet. It's almost 5 years old, but it makes a lot of sense, especially for testing the front end. So we should write tests, but not too many. We don't have to have a test for every single file and every single component. So our tests can be divided into 3 categories. So it is unit test, integrational test, and end-to-end tests. And unit tests, these are tests where we test units in isolation, so we could test components, functions, and yeah. And they wouldn't give us much of a confidence as integrational tests that the application works properly. So let's see here for an example how we define a piece of test as a unit test. So here we have a confirmation dialog that comes from our global components defined inside elements, where we want to confirm whether our confirmation dialog works properly. So here we are rendering the component, and then we want to verify that some things. So let's say here, for example, when we first render the confirmation dialog, we want to check that the title text is not being rendered, which makes sense. Then we trigger an event that should open the model, the dialog, and then we verify that we can see these values such as title and the body. And then if we click on cancel, for example, we should wait until it is not in the document and then verify that it is not visible anymore. But these kind of tests do not guarantee that our entire application will not be broken, because it is not testing the communication between the components, but only a component as an individual part. So that's where integration tests come in place, where we will test multiple units at the same time. And yeah, so they will give much more confidence that an application is working properly. And let's see in example how an integration test would look like. Okay, so here we have the discussion that comes from the discussion page, and the discussion page contains multiple different components in itself, and it uses them all together. And so here we create some fake user, so we want to represent a user as a fake user. We create a fake discussion here. We mock the use params hook from React Router DOM to have the value of its discussion ID param to the ID of the fake discussion, and then we render it, and then we do some tests. So for example here we can so we just check whether the discussion is being rendered, and we verify it by checking if it has its body or not. But then here we have should update discussion, where it should open a drawer, where it should also fill all the values. As you can see here, it should fill all the values. It should submit the form and wait for the drawer to close, and then verify that the new values are being set as the discussion's title and the body. And yes, the same would be for creating comments on the discussions, and where you can see that we are not testing just discussion anymore, but also comments and other different parts of the application in the same test. And it gives a much more confidence that our application is working properly. And yeah, so we have end-to-end tests where we test the entire application, both the front end and the back end, with some automated tools such as I like Cypress. So here we have a definition of Cypress. It is pretty flexible, where we can extend it with custom commands and plugins. And yeah, so here would be some, you could check it later, but here we have a smoke test where we can verify. If you saw the video at the beginning, it was actually generated by the Cypress. Yeah, so it generated a preview of all these commands executed. And yeah, so if something breaks here, then your test is going to blow. And so we saw these tests, but what do we use as tools to do them? So we have Jest, which is pretty standard for testing JavaScript applications. Then we have testing libraries. As we saw, we are not, so its philosophy is to test the application in the way it is being used by the user. And we are testing what the user would see when the user is using the application, and not testing some underlying implementation details, such as whether the state of the component is true or false, which is pretty relevant for the user if they cannot see what they should see in the application. And Cypress, as we already mentioned, it is a nice tool where you can automate your tests. And we have mocking data. So for all the tests we write, we would need to either mock our fetch API, or we would need to mock our API calling functions or whatever. But a good thing to use here is MSW, which stands for mock service worker, where we can mock our endpoints and use it also within our application while we are developing it, and also for testing. It would basically create a service worker that would intercept all your requests that are defined in its handlers, and then you would so let's say for example here we have the Auth handlers for the authentication API. And okay, so this is a bit overused here because we have the entire logic in the handlers, but you can mock that it always returns some user, and you would get that user when you made that request from your application. So whatever you defined within the handlers, you would it would intercept your API calls and then return the result from here instead. So whatever you return from here, instead of going outside the network and really fetch your data. When we talk about error handling, we should keep in mind some couple of things. So for example, for API errors, we saw that we are using interceptors for the API errors, and we use that to display the notifications actually. So here you can see we can access the Zustand use notification store and display the message. And it can also be used for refreshing the tokens and modifying the request. Yeah. And yeah, for in-app errors, for example, in the React tree, we have error boundaries that would be displayed once an uncaught error happens within that tree. So it is a good idea to, instead of having one global error boundary, we should wrap our functionalities, some more functionalities with more error boundaries. So every functionality have its own error boundary. So for example, if one piece of state that is in the right corner throws an uncaught error, you wouldn't blow the entire application, but you would see the error boundary meant for this specific feature that caused the error in the first place. And also, when this error happens, you should have some mechanism to track these errors. Also, Sentry is a good service so you basically upload, it will return the stack trace and everything, which browser it happened on, and if you upload the source maps, you would get the exact line of code that caused the code to break. Yeah, when we talk about security, yeah, so this is a bit of when we talk about security, there is always vulnerabilities, but let's say, for example, when we want to authenticate our user. So we need to keep in mind that we need to authenticate our user, and that means identifying who the user is, So here we have some examples on how to configure our authentication. Since we are using React Query library, we are using React Query Auth library to wrap this functionality of authentication, where we would cache the new user. We would cache it in the same cache where all the React Query cache is living. And we are doing that because the information about the user could be considered remote server cache data, because it should be up to date all the time. So here we have some configuration to handle. So handler user response is something that calls does some side effects, but then we have to define the load user function, login function, register function, and logout function, and we provide them there. And we basically wrap our code with the auth provider, and then our use auth hook is available. So we can see here, for example, how we protect our routes. We would basically just check if the user exists, give me protected routes. So protected routes plus the common routes that should be available to users, no matter whether they are authenticated or not. But then there is the authorization, where we need to verify that a user has the permission to view the resource. So for example, here we can define something like role-based access control or policy-based access control, depending on the business logic of the application. And here we have some examples, but yeah, so here is the configuration of our authorization lib. And as we discussed libs, we have the external, and this is an internal lib only used by this application. So here we have some roles, and we have policies here defined, and then we are exporting the use authorization and the authorization component, and here's how they are being used. So we would basically just wrap our code with this component and provide to it what are the roles that are allowed to see it. So if it is a user, it will return null, and it will never be, yeah. Some other security measures, and this is not complete list, but some things to keep in mind is that you should sanitize your inputs, where you would not allow some JavaScript code that, so you would not allow something that could be injected in your application and could execute the JS. So for example, preventing cross-site scripting. Then another thing to consider is removing source maps from production build. So we need to build the source maps when we use, for example, Sentry, but after we uploaded the source maps to Sentry, we can delete them from before deploying them to production. And yeah, do not store sensitive data, such as some API keys that could be too sensitive in the application. Even if you add them as environment variables, they still end up in your production build. And yeah, since it's JavaScript and Node modules, there is always some potential risks of using dependencies, and you should watch out for the vulnerable ones. Yeah, when talking about performance, there are a couple of things to keep in mind. So you should split your code and lazy load it. Mostly it happens on the route level, but sometimes you can code split and lazy load something that's on the bottom of the page to improve the speed of the application and to reduce the traffic of the initial load. Also optimizing the state in the way that you should define the state as close as possible where it's being used by the application. or the component, and you don't have to lift it up in the global state unless it is needed, because it would trigger unnecessary renders. If you keep it as close as possible, then it would re-render just this piece of code that requires it. For expensive computations, you should consider using state initializer function. So in the user state, where you will define the initial value of it, if you want to provide the initial value of that state as some expensive computation, instead of defining the value directly, you would define it, you would pass it as a callback that returns that value, because it would be executed only once, in comparison to if you provided the calculation itself, then it would so it would be executed every single time during the re-renders. And yeah, consider using build time styling solutions. If you have very frequently updated applications where you need to re-render a lot, then it's nice to use build time styling solutions where you don't have to recalculate and re-execute all the new class names that are coming for example, style components and emotion. And yeah. Also, image optimizations, such as using the right format, for example, WebP, which is better than JPEG. It has a better compression. Also, consider using source sets for responsive images, so you don't have to load a very large image if you are opening the application on your mobile. So you can specify for which screens you want which size of the image. And keep eye on the web vitals, because Google is now taking that into account when when it indexes your application and websites. And if you have a low Lighthouse or PageSpeed Insights scores, then your page would index lower than it would if it was otherwise. And also consider when deploying it to deploy it all the static assets over a CDN. So for example, good options are Vercel, Netlify, AWS, and Cloudflare, and where you would distribute, they would distribute your application assets all over the world, and it would reduce the latency of the requests when users want to access to your application. Okay, so the key points here to take away is not to just use the exact tools mentioned here, but to take this mindset and keep that in mind, that you should look for different tools for different purposes, and not just, for example, if you used to use Redux for everything, for server cache, for server-side cache, for all the states, then you should know that you have the option to choose and to find the right tool for that. And yeah, you can find the slides here on this link, and if you have any questions for later, you can reach me at LinkedIn and Twitter. And yeah, so that's about it. So thank you for listening.